Hey all, today we are going to start talking about collecting data. So far we have displayed data, we have described data, and now we're going to collect data. And we start that in chapter 10 by doing some simulations. So a random event is described as an event whose outcome we cannot predict. So if I flipped a coin, you couldn't predict what would happen. What you could do is predict what would happen in the long run. You could predict that if I kept flipping a coin, I would get heads half the time and tails approximately half the time. And so one thing we can do to sort of look at events whose outcomes are random is to create a simulation. So this is a problem from page 269 of the book. You take a second to read this, a minute to read this, and then we'll talk about how we can create a simulation about these cereal boxes. So here we have these cereal boxes that have pictures in them. A lot of cereals do this, where they have toys. So they put either a picture of LeBron James, a picture of Danica Patrick, or a picture of Serena Williams into these cereal boxes. And they're distributed in a way that 20% have LeBron, 30% have Danica Patrick, and the rest, which is 50%, have Serena Williams in there. And so what we want to do is we want all the pictures. We want one of each. And so we want to know how many boxes of cereal we should expect to buy so that we can get one of each of the pictures. And so the first thing we identify is the component of our simulation. And the component is the thing that we're going to repeat. So we want to simulate opening boxes of cereal. So the component of our simulation we're going to run is opening a box of cereal. We need to pretend or simulate what it would be like if we opened a bunch of boxes of cereal to see which picture was inside. And so now what we want to do is assign random numbers to each of the picture types. There are a couple ways to find random numbers. One is to look at a random number table. The other would be to use some sort of technology like the calculator. And we'll do both of those things together in class. But for now, we need to assign random digits to each of the picture types. So if we just look at the 10 digits, 0 through 9, we can assign them according to the distribution of pictures. So LeBron was 20%, so we'll give LeBron 2 digits, 0 and 1. We'll give Danica 3 digits to represent 30%, 2, 3, and 4. And then Serena gets the rest, 5, 6, 7, 8, and 9. And so we've distributed the 10 digits that exist amongst the 3 pictures according to the percentages that they represent. So now we would generate random digits either using a table or technology like a calculator, like I said, and we can run a simulation. So what I want to do is I want to produce random numbers until I have all 3 pictures. So every time I see a 0 or 1, that means I've got a LeBron James picture. Every time I see a 2, 3, or 4, that means I got a Danica Patrick picture. And 5 through 9 means I got a Serena Williams picture. Once I get all 3, I stop, and I would call that a trial. So our first trial, we get an 8, which is a Serena. I'll use yellow for Serena. Then we get a 9, which is also a Serena. Then we get a 0, which is a LeBron. We get a 6, which is Sabrina. And we get a 4, which is a Danica Patrick. So we've gotten all 3 pictures, and it took us 5 boxes of cereal to get all 3. So we repeated the component of opening a cereal box by generating a random number, which again I'll show you how to do. And then once we've generated enough numbers to get all 3 pictures, we stop and document how many boxes of cereal we had to open. So this all is a trial. Each of these boxes I opened is a component, and this 5 boxes is the outcome of my trial. And so we wouldn't want to just do one trial. We would want to do many trials, because you would have to imagine that it's not going to take 5 boxes of cereal every time. It might be more, it might be less. And so I've ran 8 more trials. And so you can see in trial 2, I opened 4 boxes to get all 3. Trial 3, 7 boxes. Trial 4, 5 boxes. Trial 5 took 18 boxes. Trial 6 took 6, 7 took 5, 8 took 4, and 9 took 6. So we've completed 9 trials of opening cereal boxes, and now we have some one variable data that we can analyze. We want to look at all the outcomes, the total number of boxes each trial that it took me to get all 3 pictures. And so we can put that into a list in our calculator. We can create a histogram. Might be a little fuzzy. And we can see here that our histogram looks skewed to the right. Looks like we have a potential outlier over here. Those 18 cereal boxes I opened in one of the trials. We can calculate the one variable statistics. So we have a mean of 6.7 boxes. Down here we have a median of 5 boxes. We have standard deviation of 4.4 approximately. You can see I had 9 trials and the number of trials I put in there. So the thing we want to talk about is the center. And so since this is skewed data, the thing that I want to talk about is my median. And so this a conclusion that we can draw from our simulation. And we want to make sure to say that we're basing our conclusion on the simulation we ran. This doesn't mean it's guaranteed. It's just based on a simulation we ran. We would estimate that the customers hoping to complete their card collection would need to open a median of 5 boxes. Okay, but it could take more, it could take less. All right, we documented that it's based on our simulation. It's an estimate, it's not a guarantee. We're talking about median instead of mean because we have skewed data. And so you could be not super confident, but you wouldn't be surprised if you opened 5 boxes of this cereal and got all 3 cards. So that's sort of an introduction to simulations. We'll do some simulations in class together, and of course I'll show you how to generate random numbers so that you can run the simulations on your own.